So we're given that the function is continuous at 0, 3, and it satisfies this condition. So we want to find three things. We want to find the absolute extreme values, any points of inflections, and then we're going to sketch the graph. So one of the things for me when I see all this data is really confusing for me. So what I'm going to do is I'm going to sketch a number line, just like I would any data. So I'm going to look at the first derivative. And we're given three intervals. We're given from 0 to 1. So that's what I'm going to write. And I notice that from 0 to 1, my derivative is positive. So I'm going to put a positive. The second interval is from 1 to 2. My derivative is negative. And then the last interval from 2 to 3, my derivative is negative. And the reason I write that is because now it's easier to see than all this data coming at you that from 0 to 1, my graph is increasing, and from 1 to 3, my graph is decreasing. So now I'm able to see more or less that 1 is going to be a local max. So I'm going to do the same thing with the second derivative. I'm going to draw a graph, and I'm going to put my intervals that I was given. So notice from 0 to 1, my second derivative is negative. From 1 to 2, my second derivative is negative. And from 2 to 3, my second derivative is negative. So that means that it's all concave down. So I'm not going to be a concave up, so that means it's not going to have any points of inflection. So let's go ahead and answer the first question. Find the absolute extreme values. So this is my max. So my extreme value occurs when x equals to 1. Notice that in this graph, they actually give you the coordinates. When x is equal to 1, f is equal to 2. So my max is 2, and it occurs when x is equal to 1. So my coordinate of my max is 1, 2. Part B says find points of inflections. We already talked about this. There's no points of inflection because it's always concave down. So part C, we're going to sketch a graph. So notice when I put my graph, I put it underneath the number line. It kind of gives me an idea of how it's going to look. So first of all, I'm going to plot my points 0, 0, 1, 2, which is my max, 2, 0, and 3, negative 2. So I'm going to be increasing, decreasing, so I know I'm going to be increasing, decreasing, and it's going to be all concave down. But one of the things that I'm going to notice is that when x equals to 2, my derivative does not exist. It doesn't exist, but it's continuous. So that means there's going to be no gaps. So because it's continuous, I'm going to have a corner or a sharp turn when x is equal to 2. So when x is equal to 2, I'm going to have our sharp turn. So when I draw this, okay, I'm going to draw kind of like a parabola. So notice I'm concave down, increasing, concave down, increasing. So here I'm going to be decreasing and concave down. So I'm going to kind of draw like a sharp turn to make it seem, oh, the derivative doesn't exist there. So this is a possible graph of what my graph might look like.